In this session, I am dealing with electrochemical cell. It consists of two electrodes or metallic conductors in contact with an electrolyte. An electrolyte is also called an ionic conductor. An electrode and its electrolyte comprise an electrode compartment. Two compartments may be joined by a salt bridge, which completes the electrical circuit and enables the cell to function. The second function is it maintains the electrical neutrality within the internal circuit. The two functions of the salt bridge are very important. Next is electrode potential. Electrode potential is denoted by Mn plus slash M. Mn plus slash M is the representation of the redox couple. It is the electrical potential difference setup between the metal and its ions in the solution. It is also defined as the tendency of an electrode to lose or gain electrons when it is in contact with its ions. We know that a redox couple consists of a metallic conductor in contact with its ions. Oxidation potential is explained as the tendency of an electrode to lose electron, whereas reduction potential is explained like the tendency of an electrode to gain electron. Here I have represented the zinc redox couple, and it is represented as the oxidized form / reduced form. Zn2 plus is the oxidized form and Zn is the reduced form. At each electrode-electrolyte interface, there is a tendency of metal ions from the solution to deposit on the electrode and making the electrode positively charged. And how this happens? That is, Zn2 plus receives electron from the electrode and get reduced as Zn. So this process is what? This is reduction. So as a result of reduction, there is a positive charge developed on the electrode. At the same time, the metal atom on the electrode has a tendency to go into the solution as ions, making the electrode negatively charged. And we can see how the electrode is getting negatively charged. That is, Zn from the electrode loses its electron and go into the solution as Zn2 plus ion, making the electrode negatively charged, and this process is oxidation. At equilibrium, there is a separation of the charges. We can see there is a separation of charges, positive charge here as a result of reduction and a negative charge as a result of oxidation. So at equilibrium, there is a separation of charges, and depending on the tendencies of the two opposing reactions, the electrode may be positively or negatively charged with respect to the solution. We can see that this electrode is positively charged and this electrode is negatively charged. Hence, a potential difference develops between the electrode and electrolyte, and this is called the electrode potential. The tendency to get reduced is called the reduction potential, and the tendency to get oxidized is called oxidation potential. The reduction potential of zinc redox couple measured with respect to standard hydrogen electrode is minus 0.76 volt. And according to IUPAC convention, the standard electrode potential is the standard reduction potential. In general, we can represent the reduction reaction as M n plus n electron giving m. For example, Cu2 plus 2 electron giving Cu. Al3 plus 3 electron giving Al. Here n is 2 and here n is 3. Similarly, the oxidation reaction can be represented as M giving Mn plus n electron. For example, Ag giving Ag plus electron, Ni giving Ni2 plus 2 electron. Here n is plus 1 for silver and n is 2 for nickel. The electrode at which oxidation occurs is called the anode, and the electrode at which reduction occurs is called the cathode. In short, anodic oxidation and cathodic reduction. Next is standard electrode potential, which is denoted as E0 m n+/m. It is the electrode potential in volts determined relative to the standard hydrogen electrode SHE under standard conditions. The standard conditions are the temperature 298 Kelvin, concentration of the electrolyte 1 molar, and for gases the pressure is 1 bar. Cell potential E cell. It is the potential difference between the cathode and anode of an electrochemical cell. The equation for calculating E cell is E cathode minus E anode. The standard cell potential E0 cell is calculated using the equation E0 cell is equal to E0 cathode minus E0 anode. For the redox reaction to be spontaneous in an electrochemical cell, E0 cell should be positive. According to IUPAC convention, the standard reduction potentials are now called standard electrode potentials. Next is electromotive force EMF. It is the potential difference between the two electrodes in a galvanic cell when no current is drawn through the cell. For an electrochemical cell, the anode is having negative charge. The redox couple with the lower E0 is chosen as the anode. It acts as a reducing agent. The oxidation occurs at anode, and we know that reducing agent undergoes oxidation, and the oxidation reaction is represented as M giving Mn plus n electron. Cathode is having positive charge. The redox couple with the higher E0 is chosen as the cathode. It acts as an oxidizing agent and reduction occurs at the cathode. Oxidizing agent undergoes reduction. The reduction reaction is represented like Mn plus n electron giving M solid. Daniel cell. It is the example of a galvanic cell which converts chemical energy to electrical energy. And it was invented by the British chemist John Frederick Daniel. In Daniel cell, the anode is the zinc redox couple and cathode is the copper redox couple. The E0 of zinc redox couple is minus 0.76 volt, whereas that of copper redox couple is 0.34 volt, and which is higher than the E0 value of zinc redox couple. The oxidation reaction of the zinc redox couple is represented as Zn giving Zn2 plus 2 electron, whereas the reduction reaction is Cu2 plus 2 electron giving Cu. The overall reaction can be written as the sum of the two reactions. I am going to add the two reactions, that is Zn giving Zn2 plus 2 electron, and the cathode reaction is Cu2 plus 2 electron giving Cu. The overall reaction is Zn plus Cu2 plus giving Zn2 plus Cu, where the number of electrons involved in this reaction is 2. So I am representing it as N. N is the number of electrons involved in the redox reaction. And I am going to calculate the E0 cell, E0 cell is equal to E0 cathode minus E0 anode. That is equal to 0.34 minus of minus 0.76, that is equal to 1.1 volt. This is the E0 value. And we can see that E0 cell is 1.1 volt, which is a positive value. Hence, the redox reaction occurring in Daniell cell is a spontaneous reaction.